So in this case, we are going to consider another question, which is as an application of our quadratic sequences. As we managed to work out, we just managed to work out one example, which we can work out from any of the methods that I explained before, whether you're working with the first one or the second part, as long it is a quadratic sequence where you need to determine the general term, the presentation of the nth term. So we have got a question that we are going to try by all means to use the information that we had, and also some other questions that can be asked as we are having these questions. So we are told that consider the following number pattern which we are given, and on the A part we are given that show that it is a quadratic number pattern. You must show that whatever that we are given there is a quadratic. Okay. So as we have got these terms, all right, so these are our terms, which is 6, 13, then we've got 22 and 33, and so on and so on. We do understand that when we are under a quadratic sequence or a quadratic pattern, there is a constant second difference. So in any quadratic sequence that you might be given, the second difference is constant or is common. So meaning to say that that is what we can actually use as a proof to say the second difference is constant. It is the same. So let us prove that. All right, so let us find our differences. We're going to first have the first differences from these terms that we are given: first term, second, third, and fourth. All right, so let us find the differences. That is 13 minus 6. So we need the difference between these two, 13 minus 6, which is 7. Then 22 minus 13, that is T3 minus T2. So if we had to subtract, that was going to give us 9. And we've got 33 minus 22, which was going to give us 11. As we can see, these differences that we are obtaining are not the same. Meaning to say, we have got chances of having this a quadratic, because we do understand that the first difference is whatever that we have here on our first differences is not constant. It is not common. It is not the same. So we have a guarantee that we can have a quadratic. Let's find the second differences and see. On the second differences, we are going to subtract 9 minus 7. So that is 9 minus 7, which is 2. 11 minus 9, which is 2 again. So as we can see, on our second differences here, on our second differences, actually the same. It is constant. So that's a quadratic pattern, since we have got the second constant difference. So therefore, it is a quadratic. It is a quadratic. That's a quadratic sequence or a quadratic pattern. We must have what? Second constant difference, because we have got second constant difference there. We cannot have this in any other sequence except for a quadratic. It is the only one which has got this property. That is the only one. All right. So moving on to the other part, as we managed to prove this, then they want us to write down the next two terms of the number pattern, the next two terms. So just like any other sequence that we had before, all right, just like any other part, just consider when we're working with a linear, like this part, maybe it is 7, 9, 11, like that. Then you see that there's a difference of 2, a difference of 2. You simply know that the next term, you're just going to add 2, all right, which is going to give us 13. The next one, you are going to add 2 because it is the same, which is going to give us 15. So it is that same condition. But if you check on the first differences here, it is not a constant thing. So we use the 2 that we are given here on the second difference. We know that that one is not going to change. So here the next term that we're going to have on the first differences, we know that there was supposed to be a 2 here. Whatever again that we are going to have there, we know that this was supposed to be a 2. Whatever that we are going to have there, this was going to be a 2. The second difference is constant. So we take advantage of the constant part so that it brings other terms now from the first differences, which will help us to give us the terms that we need of the number pattern. Just like that. So this is the condition that you can simply use. As we have illustrated here, 11 plus 2, this is the condition. 11 plus 2 here was going to give us 13. 13 plus these 2. Or you can finish up, since we have got 33 here, we can say 33 plus 13, we obtain the next term. That is the condition. So we're simply going to add 33 plus 13, which is 46. All right. Then we can come back to the 13 as we are continuing this, because here there's just same presentation. So 13 plus 2 is going to give us what? That's 15. This one. So we've got 15 here. Then we continue from the 46. Add this to what? To 15. What are we going to have? That is another term. So this is 46 plus 15. So if we are to add 46 plus 15, all right, this is what we are supposed to add. That was going to give us what? 61. Thus, we've got the two terms that are following. So if we wanted another term again, we're going to do this. Go back to the 15, add 2. That was going to give us 17. Then the 61 to 17, we obtain that term, just like that. The same thing, whatever that we're going to have, where there's a 2, we add, this is 19, whatever that you have here, you add, and so on and so on. So the pattern is going to continue like that. So in this case, we need only these two, the next two terms. So that's 46 and what? And 61. So that is what we're going to have here. So the next two terms here were 46 and 61. Okay. Then let us move on to C, which is actually the major part of the application of those formulas that we have been working with in our previous class, where now they are saying, hence, on C, hence determine the nth term as well as the 100th term. So let us start with the nth term, the general term. Already we know it's a quadratic. We have proved that. So this one now is the question that is the one that we dealt with in our previous class. And remember what I said, I actually told you guys that it is in your hands for you to attempt this question. Are you going to use this part? All right, since we have already calculated, we know our first differences and also the second one. So we can use this idea that 2a is equal to the second constant, 3a plus b is equal to t1. All right, then, or we can use the other one. So I'm just going to use both for the sake of a revision. All right, for the sake of revision. So let's start with this one, guys. All right. So here we said, if we are given this condition, we are going to equate 2a to the second constant difference, 3a plus b to the first term of the first differences, then a plus b plus c to what? To t1, which is from the original sequence. So this follows that we simply take our terms. Remember, I told you guys you take these ones this way, going up. So meaning to say we are considering the 2, the 7, and the 6, where the 2 is the one that is equivalent to 2a. So 2a is equal to this. On this part, this is our 3a plus b, which is equivalent to 7. Then the 6, which is our first term, that's our a plus b plus c, which must be equal to this 6. Remember that. That's when you're using this. So you take advantage of what? The 2a, you work it from down, from this going up. Down, going up. All right? So 2a must be equal to what? To 2. If 2a is equal to 2, which is our second difference, therefore we can calculate the value of a by what? Dividing by 2. Okay? We move on to the other part, which states that 3a plus b must be equal to what? To the first term of the first differences, which is the 7 there. So 3a plus b is equal to 7. This one you just need to memorize this part. Once you are done with that, you can answer any question, all right? It's all about the method that you're using, guys. We already have calculated the value of a. Remember, a is 1. So in place of a, substitute the one that you obtained. So that's 3 times 1 plus b, which is equal to 7. So you can solve for b. 3 times 1, that is 3, plus b, and that is equal to 7. So you can take the 3 to the other side of the equation, which was going to be a negative there, or simply subtract 3 both sides. So 7 minus 3, that is what? That is 4. You have the value of b. You are left with c. From where the first part, a plus b plus c, is equal to 6, which is our t1. So we can take that a plus b plus c is equal to what? To 6. Where we have calculated our a, b, so we can substitute these two. We have got their values. All right, so let's substitute. Remember, a is what? Is 1. Our b is what? Is 4 plus c. This must give us 6. So 1 plus 4, that was going to be 5. Okay, that's equal to 6. Then to solve for c, we can simply subtract 5 both sides of our equation. All right, so c is equal to 6 minus 5, which is what? Which is 1. So we have a, b, and c. The constants from our general expression. from the general presentation of our quadratic a n squared plus bn plus c. Whenever you forget this, go back to your quadratic functions. Go back to your quadratic function. When you had a function of y is equal to ax squared plus bx plus a quadratic, it is the same thing that we are talking about here. Only that your x is now represented by n, the number of terms. So whenever you forget this, remember at least your general presentation of a quadratic equation or from your quadratic functions. Then you can relate from there. All right. Anyways, let us substitute our values that we calculated a. So therefore, our nth term was going to be given as, in place of a, we're going to put 1. So that's 1 times n squared, which is n squared. In place of b, we are going to put a 4. So that's 4 times n, which is 4n, plus, in place of c, we're going to put a 1. So that is it. A quadratic. A quadratic. So the major part of these questions is to formulate the expression from your understanding here. As long as you understand how to, then it's fine. So as we can say, if you understand this way, it can be an easier way. And I actually want you guys to work out with this idea. Not to say the other method is bad. No, it is still one and the same. Guys, it's mathematics. How you understand it. How you understand it. So let us also have another way for the sake of others who are using this way of working out simultaneous equations. All right. Since we do understand that our nth formula is given by this, where we have got a, b, c as constants, we can calculate those first and second differences which are already there. Then we calculate the value of a from 2a is equal to the second difference, of which we already calculated that, guys. Remember, we said that's a is equal to what? To 1. Then taking any two terms, we are going to substitute so that we formulate simultaneous equations where we can solve for what? For b and c. And I said elimination method there is the best. Any two terms of your choice. So it is best for you to just work out first and second so that you do not have confusion. So as for me, I'm going to take the first term. So from T1, the first term, T1 is equal to what? To 6. Okay. The second term, T2, is what? 18. So what does it tell us here? Tells us when n is 1, our answer is 6. When n is 2, our answer is 18. From where? From that general term, Tn is equal to an squared plus bn plus c. Remember, we have already calculated our n, so our a, so we substitute that a here, that's a 1. So 1 times n squared, that's n squared, plus bn plus c. So this is what I'm trying to say. As we have got T1, which is equal to 6. T1 here, which is equal to 6. It simply tells us that n is 1. Remember, it's Tn. Tn. So we are told here that n is what? For a condition that n is equal to 1. In place of n, put 1. You must obtain 6. So it simply tells us that. All right. So let me formulate the equation here. So for our equations, 6 here is equal to In place of n, let's put a 1. So that's 1 squared plus bn. So that's simply b times 1 plus what? Plus c. So that's it. So 6 is equal to 1 squared, which is simply 1 plus b plus c. Take this 1 to the other side, it was going to be a negative. So 6 minus 1, which is 5. So 5 is equal to b plus c. It's an equation, guys. A, where we've got b and c there, as our unknown, two unknown values. Okay? Let's do that. For T2, we are given that it is equal to, or it is equivalent to 13. For a condition where n is equal to 2. When n is equal to 2, we must obtain 13 in place of n. So 13, all right, let's formulate another equation. 13 is equal to, we substitute in place of n. We substitute what? 2. So in place of n, that is 2 squared plus bn, that's b times 2 plus c. All right, so 13 is equal to 2 squared, which is 4, plus b times 2, that's simply 2b plus c. So we're going to take the 4 to the other side, or simply subtract 4 both sides of your equation. That's 13 minus 4, which was going to give us what? Which was going to give us 9. So 9 is equal to 2b plus c. Another equation being formulated. So we have got two equations with b and c as unknown. So solve simultaneously. Solve these two simultaneously. All right? B plus c is equivalent to 5. 2b plus c is equivalent to 9. That's our second equation. Elimination is the best because we already see that the part of c here is the same. Of course, same coefficient, 1, 1. So simply subtract equation 1 minus equation 2. Just like that. So let's subtract b minus 2b. That's 1 minus 2, which is minus 1. So it's minus 1b, which is simply minus b. 5 minus what? 9. So 5 here minus 9. That was going to give us negative 4. All right. So divide by negative 1 to get rid of this negative on b. That was going to give us a positive 4. So with this value of b, we can substitute in any one of these equations, guys. This is now the part of substitution. Just substitute in the first equation. B plus c is equal to 5. We've got our b, which is what? Which is 4. So in place of the b, you're going to put a 4 here. So that's 4 plus c, which is equal to 5. So subtract 4, both sides of your equation. That c is equal to 5 minus 4, which is what? Which is 1. So it is enough for us to have our quadratic presentation of this number pattern, as we have got now the value of b and c. Remember, a is already substituted here. So therefore, our nth term is going to be given as n squared. Remember, we substituted a here and it was 1. So we need b, and our b is what? From here, our b is 4. So we're going to substitute that here. So that's plus 4n plus our c. Remember, our c, when we calculated, it was what? A positive 1. So this is it. Same as what we obtained before. So that is why I always say this type of a question, it is actually in your hands. You play around it the way that you want or the way that you understand. All right, so let's have a continuation as we can see from that same part of the question. Remember, we were on C, so we managed to calculate our Tn. We said it's n squared plus 4n plus 1. All right, is that so? Okay, that's it here. So from there, there is also another question here because they are saying as well as the 100th term, as well as the 100th term. N, when it is equal to 100, what is the value of Tn? What is the value of T100? That is what they are asking you there. As a continuation, already our Tn is there. So T100 simply means in place of N, substitute 100. So that's 100 squared plus 4 in place of N, that is 100, all right, plus 1. You substitute, all right. So with this, we can simplify. That is to obtain the value of T100. So here you can simply use your calculator, guys, to simplify everything. You can simplify stage by stage. It is in your hands. You're going to obtain 10,401. So that is how these questions can be given as. You need to work out as many questions as you can. As many questions. So if we consider, let's see another part, which is on D. So the D part, they're saying determine which term equals 118. All right. We had such questions even for those linear or arithmetic sequences. Remember, there were questions like that. Knowing that our Tn is equivalent to n squared plus 4n plus 1, this type of a question is not supposed to surprise us because we have what equals the Tn. Determine which term equals 108 to say our Tn is the one that is equivalent to 118. So which term are we talking about? Which n are we talking about? That when we substitute in this general term, we must obtain 118. So it's not a trial and error question that you must try terms until you get 118. Since these two represent the same thing, which is our Tn, therefore we can simply equate their equivalent part here. We can equate what the Tn is equivalent to n squared plus 4n plus 1. What about this one? It is equal to what? 118. And these two, they represent the same nth term, the same Tn. So they are equal. Meaning to say, an equation has been formed from there. We have formed an equation which we can solve for n. And that's a quadratic, remember? Highest exponent being 2. So that's n squared plus 4n. So just going to take the 118 to the other side. That's subtract. So it's going to be negative there. That's negative 117. All right. Negative 117, which is equal to 0. A quadratic equation, you can solve these guys from any way that you understand. Is it the quadratic formula, the use of that quadratic formula? Is it the factorization? It is in your hands. Since we have got the coefficient here of n squared being 1, we can just try, guys, to work out with factorization. Since we understand that if we've got a 1 here, this is just going to be n, this is going to be n. N times n to give us what? N squared. So you focus on the product of this number, the constant, the products, two numbers that when you multiply them, they will give you minus 117. But when you add the two numbers, you must get what? Positive 4. Multiply two numbers, you must obtain negative 118. So which numbers are we talking about when you multiply them? There is 9 and 13. It gives us 117, these two numbers. But the case now is supposed to be, if we multiply 9 times 13, we've got 117, a positive. But the case is supposed to be negative. So let's put a negative on this one. And another one, let's put a negative on 13. So that when we add, we want to see which part, when we add, we must obtain a positive what? A positive 4. So here, if we add, we're going to get a negative 4, which is wrong. If we take this one, minus 9 and 13 and add, we're going to get a positive 4. So this is exactly what we want. The product gives us minus 117. The sum gives us what? 4. So these are the numbers. Negative 9 and what? And 13. So we can solve for n. As we have got the two brackets, we do understand each of these must be equal to 0. So n minus 9 being equal to 0, or n plus 13 is equal to 0. So from there, we have got the values of n. Take this to the other side. That was going to be a positive, or our n is equal, take this to the other side, that was going to be a negative. And talking about number of terms, there is no way that we can refer to number of terms as negative. As long we are talking about number of terms, our n is supposed to be greater than 0, being an integer, a whole number that we're talking about, an integer greater than 0. So therefore, our n is 9, which is a positive value that is greater than 0. So therefore, our n is equal to 9. That is the condition. Which term? Determine which term. What is the value of n there when our Tn is 118? Which term? So these are the questions. Try as many questions as you can understand these typical questions. So in our next classes, we shall be focusing on question papers now, as we have got the basics of our linear, which is the arithmetic sequences, and we also managed to work with this type of a quadratic, where we've got a quadratic number pattern. So with this, I think it can help us as we shall be attempting question papers. So as an individual, please go through each and every part that we have discussed under our number patterns, starting from the linear, which is the arithmetic, the basics, everything, because now our classes, the next classes that we shall be dealing with, shall be focused on exam questions, because we shall see that it's just a repetition. We keep on doing like one question. So the best that we can actually use in terms of our understanding is the use of what? The question papers. At least we try to figure out how they can change the questions when you are in exam. So that is it, guys. Till we meet again.